Hello. The law of cosines is used in trigonometry to solve oblique triangles, and it is applied in two specific cases. In one case, we are given two sides and the included angle, and this case is called side-angle-side triangle, and in the second case, we are given all three sides, and this is called side-side-side triangle. In this video, we will see how to use the law of cosines to solve a side-angle-side triangle. If in a triangle we know two sides and the included angle, and we need to find the missing side and the missing angles, then we need to take the following steps. In step 1, use the law of cosines to find the side opposite of the given angle. So if in this triangle we are given angle A, then in the first step we will use the law of cosines to find side A. In step 2, use the law of sines to find the angle opposite the shorter of the two given sides. For example, if in this triangle out of these two sides, side B is the shorter, then we will use the law of sines to find angle B. In the following example, I will explain why it is necessary to identify the shorter side when using the law of sines, and why you might want to use the law of cosines instead. And now, in step 3, find the third angle by subtracting the other two angles from 180 degrees. So if we know angles A and B, then we can find angle C by subtracting these two angles from 180 degrees. Now here we have a triangle with side B of 14.2 units, side C of 9.5 units, and angle A of 35.7 degrees. So this is a side-angle-side triangle because we are given two sides and the included angle. Then in the first step, we will use the law of cosines to find side A because this is the side opposite of the given angle. Now here we have the law of cosines, and if we take the square root on both sides, then we get A equals square root of b squared plus c squared minus 2bc cosine of angle A. If in this formula we replace the given data, then we will have A equals square root of 14.2 squared plus 9.5 squared minus 2 times 14.2 times 9.5 cosine of 35.7 degrees. Then here we will use a calculator, and depending on the model, you might need to use extra parentheses. First you will have the degrees in parentheses, and make sure your calculator is in degree mode, and you might also have to enclose in parentheses the whole expression under the radical. Then A is approximately 8.53 units. Next, according to step 2, we will use the law of sines to find the angle opposite the shorter of the two given sides. From the figure, we see that side C is the shorter out of the two given sides. So then, we will use the law of sines to find angle C, because this angle is opposite the shorter side. For this, we will form a proportion, and because we need angle C, one ratio will be side C over sine of angle C. Then another ratio will be side A over sine of angle A. And we use this ratio because now we know side A and we know angle A. If we replace, we will have 9.5 over sine of C equals 8.53 over sine of 35.7 degrees. Then if we use cross multiplying, we will have 8.53 times sine of C equals 9.5 times sine of 35.7 degrees. Next, we will divide both sides by 8.53 Then sine of C equals 9.5 sine of 35.7 degrees over 8.53. Now to find C, we will use the inverse sine of 9.5 sine of 35.7 degrees over 8.53. Again, have the calculator in degree mode, and C will be approximately 40.53 degrees. So far we found side A and angle C. And now, before we find angle B, let's address the question why we had to use the shorter side for the law of sines. First, we need to know that triangles either have only acute angles, or if they have obtuse angles, they will have only one obtuse angle. In this triangle, if you go ahead and subtract these two angles from 180 degrees, then you will see that angle B is an obtuse angle. But these two are acute angles. We also need to know that in a triangle, the shorter side is opposite the smaller angle, but the longer side is opposite the larger angle. So if a triangle can have only one obtuse angle, then that is not going to be angle C, because angle C is opposite the shorter side. So you see, the idea is that out of these two angles, first we want to find the smaller one, because the smaller angle for sure will be an acute angle. But why do we need to find the acute angle first? This is because of the range restriction of the inverse sine function. When using a calculator to find an angle with the inverse sine function, the result will always be an angle from negative 90 degrees to positive 90 degrees. This means that obtuse angles will not be directly displayed by the calculator. So let's see what happens if, by mistake, instead of side C, which is the shorter side, we use side B and we try to find angle B. For this we will write side B, which is 14.2, divided by sine of angle B equals side A, which is 8.53, divided by sine of 35.7 degrees. If we use cross multiplying, we will have that sine of angle B equals 14.2 times sine of 35.7 degrees divided by 8.53. Then B equals inverse sine of 14.2 sine of 35.7 degrees over 8.53. And if we use a calculator, then B is approximately 76.27 degrees. However, this is not correct. If we go and subtract these two angles from 180 degrees, we will see that angle B is approximately 103.77 degrees. So then, why the calculator is displaying 76.27 degrees? First of all, this angle is in the range between negative 90 degrees and positive 90 degrees. This angle is the angle of 76.27 degrees, and as you see, it is an angle in quadrant 1, but this angle measures 103.77 degrees and is an angle in quadrant 2. Both these angles have the same value of sine. That is, sine of 76.27 degrees is the same as sine of 103.77 degrees. Then out of these two angles, because of the range restriction, the calculator will display this angle. So as you see, if we use the law of sines, we need to play safe and find the angle opposite the shorter side, because that angle for sure is an acute angle. Another alternative for step 2 is to use the law of cosines. While the formula is a bit more complex than the law of sines, it offers a significant advantage. And that is, it doesn't matter which side of the triangle is used in the calculation. So if in step 2 we want to use the law of cosines, then it doesn't matter if we want to find side B first or side C. And that is because when we use the inverse cosine function, then the result will be an angle from 0 degrees to 180 degrees. So if it happens that the angle is an obtuse angle, then the calculator will display it directly. Now, if we still want to find angle C first, then we will use this formula. And this is because this formula uses angle C. And if we solve this formula for C, then we get C equals inverse cosine of a squared plus b squared minus c squared over 2ab. Then if we go and replace, we will have C equals inverse cosine of 8.53 squared plus 14.2 squared minus 9.5 squared all over 2 times 8.53 times 14.2. And here again, depending on your calculator model, you might need to enclose both the numerator and the denominator in parentheses. So you might need these two sets of parentheses. Then C will be approximately 40.52 degrees. And this is pretty close to the value we got when we used the law of sines. For a more accurate value of C, we would need to use more digits of the approximated value of side A. And now, once we know angle C, to find the third angle, we need to subtract angles A and C from 180 degrees. So angle B equals 180 degrees minus 35.7 degrees and minus 40.53 degrees. Then angle B is equal to 103.77 degrees. So now we have all the missing parts of the triangle and the problem is completed. If you liked this video, please give me a like and subscribe to the channel. Thank you for watching.